Hello, and thank you very much for coming along once again. This evening we're going to look at a very interesting question, and in particular at remote parts of the world that you may think have nothing to do with where we are. That's what we're going to explore a bit, and particularly the link between those remote parts of the world and our own circumstances. We're going to look at penguins, polar bears, and civilization, vanishing polar ice, and human climate vulnerability, both in Antarctica and in the Arctic Circle. We'll look at Arctic ice and the Antarctic ice. Something very important has happened this week in changing the ice profile of Antarctica. And it's a good time to remember the connection between penguins, polar bears, and their habitat, and the civilization we've all come to be used to. And in fact, we're gradually becoming aware of the fate of animals at the end of the earth, like the penguins, because there have been some very powerful documentaries made on the life of the emperor penguin in particular, and the king penguin, close relative. And we've all become attached, in a sense, to these charismatic little birds. A film called March of the Penguins made it through the feature movie circuit and was quite a phenomenon for a while, getting us all to realize what an arduous life they had and how precarious it was. Polar bears cling to the last remaining pieces of ice in the Arctic as well, and they too have become sort of symbols, charismatic megafauna, as it's often referred to, symbolizing the crisis of climate change on Earth. They can swim, but only for a certain distance, and as the ice packs disappear, the swimming is more and more arduous, and polar bears are starting to drown, because they hunt seals from ice packs. Now, if the ice packs disappear, their ability to hunt seals from the ice packs disappears, and their capacity to live is diminished. These animals are under threat of extinction because their habitat is changing. But some would say, and some do say, in fact, so what? Who cares about animals at the ends of the Earth, the North Pole and the South Pole? You and I are never going to go there. We're probably never going to see anybody who has gone there, unless we go to slideshows or go to a movie like the one, The March of the Penguins. It's all secondhand, and we kind of get the feeling it's not really related to us. Well, that's not true, but it's hard to keep that in mind. Scientists and citizens care because the habitat change at the ends of the Earth has direct implications for the survival of our civilization. People like Eric Rignon, a government scientist also working at the University of California in Irvine, as well as NASA's Jet Propulsion Laboratory, have studied Greenland in great detail, and they're beginning to come up with some very alarming information about the change in the habitat for polar bears in the whole Arctic North, but especially along glaciers melting into the Atlantic on both sides of the Greenland continent. They've written it up in a thing called The Hidden Meltdown of Greenland. It's really quite staggering. And why it's hidden is that it's largely taking place underneath what's seen at the surface. Initially, scientists looked at the surface temperatures and looked at the protruding glaciers that were coming out of the mouths of various estuaries, and they calculated how long would it take to melt. And it wasn't very swift, because the temperature of the surface waters was cold and the temperature of the ice was cold, and it didn't seem that there was much erosion from that end of things. But what Eric Rignon and others have done is do very sophisticated radar through the ice shelves, looking underneath them, and the advancement of these glaciers, and looking at the difference between the ground down here, the glacier that's advancing, and the cool water that comes from the melt up here. Sure enough, the cold water is characteristic of the top layers, but the warmer water is coming up from the tropics and eating away that ice shelf from underneath at a much faster rate than any scientist predicted. Scientists predicted the warm water would mix up here, and then there would be a melting on the edges and the like. But it's not happening that way. It's happening with warmer water coming in underneath, undercutting the glacier, in effect cutting back its support, and that's breaking off then as these little wedges get thinner and thinner. It's extraordinary when you look at it. That's why it's called the hidden meltdown, because it's not visible from the surface, but it's occurring much more rapidly than anyone thought. It's hidden from the surface, but now that scientists have the techniques to look down through the X-ray, in effect, from satellites that enable them to look through to the level of the ground itself, they can see what's happening and why the glaciers are calving at a much faster rate than they thought they would. Now in Antarctica, this story is even more dramatic in a way. In fact, let's take a look at it, because the same processes are going on, but on a much bigger scale.
Over the years, as temperatures around the world have ratcheted upward, climate change researchers have kept a wary eye on one place perhaps more than any other: the West Antarctic ice sheet, and particularly the fastest melting part of it, the glaciers that flow into the Amundsen Sea. In that region, 6 glaciers hang in precarious balance, partially supported by land and partially floating in waters just offshore. There's enough water frozen in the ice sheet that feeds these icy giants to raise global sea levels by 4 feet, if they were to melt. That's troubling because the glaciers are melting. Moreover, a new study finds that their decline appears to be irreversible. "We've passed the point of no return," says Eric Renaud, a glaciologist working jointly at NASA's Jet Propulsion Laboratory and the University of California, Irvine. Renaud and colleagues have used 19 years of satellite radar data to map the fast-melting glaciers. In their paper, which has been accepted for publication in Geophysical Research Letters, they conclude that this sector of West Antarctica is undergoing a marine ice sheet instability that will significantly contribute to sea level rise in the centuries ahead. A key concept in the Renaud study is the grounding line, the dividing line between land and water underneath the glacier. Because virtually all melting occurs where the glacier's undersides touch the ocean, pinpointing the grounding line is crucial for estimating melt rates. The problem is, grounding lines are buried under thousands of feet of glacial ice. It's challenging for a human observer to figure out where they are, Renaud explains. There's nothing obvious that sticks out on the surface to say, this is where the glacier goes afloat. To find the hidden grounding lines, they examined radar images of the glaciers made by the European Space Agency's Earth remote sensing satellites from 1992 to 2011. Glaciers flex in response to tides. By analyzing the flexing motions, they were able to trace the grounding lines. This led to a key discovery. In all the glaciers they studied, grounding lines were rapidly retreating away from the sea. In this sector, we are seeing retreat rates that we don't see anywhere else on Earth, Renaud says. Smith Glacier's line moved the fastest, retreating 22 miles upstream. The other lines retreated from 6 to 19 miles. As the glaciers melt and lose weight, they float off the land where they used to sit. Water gets underneath the glacier and pushes the grounding line inland. This, in turn, reduces friction between the glacier and its bed. The glacier speeds up, stretches out, and thins, which drives the grounding line to retreat farther inland. This is a positive feedback loop that leads to out-of-control melting. The only natural factor that can slow or stop this process is a pinning point in the bedrock, a bump or projection that snags the glacier from underneath and keeps it from sliding toward the sea. To investigate this possibility, the researchers made a novel map of the bed beneath the glaciers, using radar and other data from satellites and NASA's Airborne Ice Bridge mission. The map revealed that the glaciers had already floated off many of their small pinning points. In short, there seems to be no turning back. At current melt rates, concludes Renaud, these glaciers will be history within a few hundred years.
These glaciers will be history. Actually, there's a heck of a lot of the world that will be history as these glaciers turn into water. And that's what we want to look at very quickly and alarmingly, in a sense. The Pine Island Glacier is a good example. The melting goes on not at the surface, where they were initially looking. It goes on down here. As you saw in the illustration, that changes the grounding line and that changes the break-off point over time of these glaciers. And there is no turning back at this point. From now on, it's inevitable. Guess what? There's no stopping the processes that will be set in motion as a result of that downward hill flow of ice into the oceans. There's a lot that hangs on that. Take a look at what Jim Hansen said.
Antarctica, the world's greatest freezer, is melting. Trillions of gallons are draining into the oceans. Sea levels are rising. It's happened before, and it's happening again, right now.
It's not a question of will sea level rise a large amount. It's only a question of how fast that will occur.
Okay, not a question of whether it'll happen, just a question of how fast. That's why we should be very interested in the habitats of polar bears and penguins at this point. This isn't something that's that remote from us at all. In fact, it's increasing in its phenomena and its Arctic importance because of the thawing of frozen mud or permafrost. This is happening at an accelerated rate too. It's being called the sleeping giant in the Arctic. It's a positive feedback loop. The more it melts, the less snow is covering the ground. The more the ground is brown or green and is absorbing more and more sunlight. It's a tipping time bomb. And I'd urge you all to go out and listen to these interviews of these scientists on this. It's just staggering.
When the permafrost thaws, the organic matter in the permafrost thaws as well and begins to decay. The microorganisms start to eat it. If there's no oxygen, the microorganisms make methane. If there's oxygen, the microorganisms make carbon dioxide. Permafrost. Right here. Frozen dirt.
Okay, well, frozen dirt is becoming unfrozen and it's releasing CO2 and methane. Methane, which is far more powerful than CO2 in trapping greenhouse heat at the Earth's surface. This week, July 13th, there was amazing news from Antarctica.
In breaking news, ice breaking that is, one of the biggest icebergs ever recorded broke away from the Larsen C ice shelf in Antarctica on Wednesday, in the latest sign that climate change will drive sea levels to rise dramatically over the coming decades. The iceberg weighs an estimated 1 trillion tons and is roughly the size of Delaware. Geophysicist Edward King of the British Antarctic Survey said the iceberg itself won't contribute to sea level rise, but that if the entire ice shelf breaks apart, Antarctica's glaciers could soon begin spilling into the ocean.
If you look at all the ice in Antarctica, you're talking about many meters of sea level rise potential. But we're not talking tomorrow. We're not talking next year. It'll be a process that will take time. But we think that in places that process has started.
Has started and it won't reverse. It's absolutely irreversible. This is why the study of Earth underwater has taken on an emergency kind of character to it. I'd urge you to watch the documentaries. What will be happening to the world's global sea levels as that Antarctic ice moves into circulation? Well, we can take a look at places like Miami.
One city that would face inundation this century is Miami, Florida. Just a few feet above sea level, it has virtually no defenses against a rising ocean. After 1 foot of sea level rise, these beaches would be regularly flooded at high tide. After 2 feet, many roads would be submerged. After 3 feet, if a hurricane strikes, the surging water would overcome sea defenses and cause flooding deep inland. Much of the region's coastal real estate would be ruined.
We're looking at millions and millions and millions of dollars of real estate here. And we can assume that every one of these things is $500 million to $1 million. We've got 100 here, we've got 100, we've got $1 billion in a very short area through here. So our $1 billion of houses, we get 1 meter, 3 feet of sea level rise, and every single one of these houses is useless. Who's going to buy it? What happens to this $1 billion of real estate by the time we get 3 feet? I mean, it's gone. It's useless. It's just, you scrape it off with bulldozers and you just leave it here. That's what will happen. It'll just be left here.
It'll just be left here, scraped off with bulldozers and left here. I mean, it's really quite extraordinary that millions, hundreds of millions, billions of dollars of real estate are going to go by the end of the century. This isn't a casual shift, and we ought to be spending time looking at where the penguins and the polar bears live, because, in effect, it's going to have an implication for us directly.
By 2100, after 6 feet of sea level rise, Miami would look like this.
There's no way to prepare for this. You can't put levees around the kind of sea level rises we're in for. We're a city that's only a little over 100 years old. We became a town, an incorporated town in 1896, so we're not that old. But we may not make it for the next 100 years.
The only way to prevent Miami from flooding would be to construct a vastly expensive system of levees surrounding the city. It would be a major engineering challenge, as Miami is built on porous ground that allows seawater to seep through. Alternatively, if Miami was flooded, the city would eventually have to be abandoned.
There are cities you can save and cities that you can't save. And the choices will be based on, can we dike it off, can we put it off, or is this too expensive, not worth the price, not worth the effort?
That's it. That's the choice. Cities you can save and cities you can't save. And that'll be the question. At the same time, there's a kind of real estate boom going on in Miami. People are buying condos at a great rate. But they're going to be inundated. Same is true in San Francisco, the Mediterranean Sea, and here in Boston. What's the fate of the post-Columbian city all over the world? We've begun to ask the question, are you climate ready, Boston? New York, Philadelphia, Baltimore, Washington. In effect, no one is. This was a speech given over at the Boston Public Library by Bud Riss. He's part of the Green Boston Commission and former head of the aquarium. Gave a speech this last month, in effect, on is Boston prepared for climate change? The answer is not encouraging. We are not ready for climate change, and it's going to hit us faster than we ever thought. Get over to the Leventhal Map Center at the Boston Public Library and take a look at what's at stake here, because city after city in the world is going to be inundated on a scale we've never seen. Take a place that isn't really a post-Columbian city. Hong Kong was in place long before the Europeans got there, but the European growth in trade over the last 500 years has made Hong Kong a center. 2 degrees centigrade increase is going to inundate that. 4 degrees centigrade increase is going to turn Hong Kong into a Venice. all its streets are going to be flooded. Here too, there's fear of a property market crash as people try to get out. They're trying to get in at this point. They're trying to buy up Hong Kong real estate. But when it becomes apparent that that's all going to be flooded, people are going to be trying to get out. Now, the results of this has been pointed out at the UN years ago, that in calculating the true cost of fossil fuels, we need to include the coming vulnerability of those who live in the post-Columbian city, which is most of us on seacoasts. Take a look. We're facing the fact that we've done cost-benefit analysis and looked only at the benefits, not looked at the costs. The whole carbon bubble, the carbon moment in human history, is one great big gaspillage of a resource with no cost accounted for in terms of its impact on a global functioning ecosystem. If those costs were internalized, you'd be paying $57 a gallon for gas, right? So, yeah, we got to get the metrics straight, but we also just have to move off of carbon. Not because it's becoming more scarce. A few years ago, we used to think, on one of the graphs I used, it was the peak oil question that was the great anxiety. We're going to run out of stuff. Well, in fact, we're not going to run out of fossil fuels in any known future, especially with the new technologies used in fracking and the like. It's not the scarcity of the material, it's the impact of the material. We can't survive using that amount of carbon. Just on the post-Columbian city basis. Post-Columbian cities are those that were put in place after Columbus discovered, as it were, the New World. He didn't discover it because it wasn't lost, right? But in any case, the post-Columbian city was put in place, pretty much, at sea level. Because that's how we got here, right? On a boat. The post-Columbian city is under challenge. If you didn't see the graphic here, 1,400 cities in the United States alone. We can't survive in those cities with the combustion of terrestrial carbon. This is why the new movement that's emerging is called the carbon underground. We're trying to keep the carbon underground. And you start doing the metric for that, you measure progress in a very different way. Not how much carbon have you used, but how much have you sequestered? How much have you prevented from being used? Well, that's the issue, and it'll be a good question to see if we can prevent more carbon from being used to save the habitats of the penguins and the polar bears. As Sir Nicholas Stern pointed out, emissions are growing faster than we thought. The absorption capacity of the planet is less than we thought. The probability of high temperatures is likely higher than we thought, and some of the effects are coming faster than we thought. Those effects are going to need a new kind of alliance between citizens and scientists around the world to work together to devise a transition to a sustainable future. It's not complicated, really. We are now a fossil fuel-driven civilization. We need to become solar sustainable. This will require a major transition. People everywhere now understand that transition studies are crucial for human survival.
This is Noam Chomsky. You're watching Cambridge Community TV.